Hey guys, so use this video to check your answers to today's part 2 study guide. So again, feel free, please. I encourage you to use this video to double check your answers. If you haven't completed the problems up above, go up and try it. Take like a practice test, then come back down and check your work. So problem number 1 here, we have a right triangle and it says solve for x. So we should be using trig here. So we're gonna write TOA, right? I know I should be using sine, cosine, or tangent to help me out. Well, let's begin by putting our reference angle. Where should that go? Well, put it where the angle that they give you here. They give me that this angle here measures 35 degrees. Let me go ahead and place my reference angle there and label everything accordingly. If I go directly across from that, that is considered my opposite side. Next, I would find the 90 degree, that perfect corner, and go directly across from that. That is your hypotenuse, always will be. Always across that 90 degrees is your hypotenuse, and that just leaves this last one down here as our adjacent. So once you're done labeling, ask yourself, what do they give you and what are we trying to find? Well, they give us the hypotenuse, we're trying to find the opposite side. So what uses opposite and hypotenuse? That is going to be sine, right? The so part in SOHCAHTOA. Well, what does so stand for in SOHCAHTOA? Remember, that's just saying that sine of our reference angle is equal to O, which is the opposite side, over H, which is our hypotenuse. So let's go ahead and fill in everything that we know to set up our trig ratio here. So we're going to write sine. Instead of theta, I know theta. Theta was 35 degrees, is equal to my opposite side. Well, opposite side here is x, over the hypotenuse, which is 8. Okay, so let's go through. We don't have x all by itself. We still have to go through and do a little bit of work. So let's get rid of that fraction by multiplying by 8, right? The inverse of dividing by 8 is to multiply by 8. So we're going to multiply both sides here by 8. 8 times sine of 35 is what I bring down on the left. 35 degrees is equal to, and then the 8's canceled out, so we're left with just x. If we can correctly plug that into the calculator, that should tell us our missing side over there, x, that opposite side. So let me change 8 times, whoops, where is my calculator? All right, so I was having trouble finding my calculator, my Desmos calculator. So 8 times sine of 35, I think I have it back up. There it is. 8 times sine of 35 degrees is going to give us 4.58. 4.58 gives us 4.58. Oops. 4.58, and I think it also said 8 after that, is equal to x. Now, they didn't tell us to round, so we're going to go ahead and round this answer to the nearest hundredth, just 2 spaces after the decimal, so this will be 4.59 units. Okay, so again, that is the distance of this opposite side over here, this opposite side that is x. And again, if I don't tell you how to round, go ahead and round to 2 spaces after the decimal. Again, think of money. All right, problem number 2. One more time, solve for x. So again, they don't ask us to round, so we're going to round to 2 spaces after the decimal. So here, let me write SOHCAHTOA up above. So, all right, let me go ahead and label everything based off my reference angle. So I see that there's a 12 degree there. I'm going to go ahead and stand there. I'm going to place myself there, and I walk across this triangle to the opposite side, and I'm going to label that opposite. Once I do that, I find my 90 degrees, that perfect corner, walk across that 90 degrees. Other wall over here is your hypotenuse. Always across your 90 degrees is your hypotenuse. And that means that our last side down here, 8, is representing our adjacent. So once we have that, well, what do they give us? Adjacent. What are we trying to find? Hypotenuse. What uses adjacent and hypotenuse? That is going to be cosine. Take a look at SOHCAHTOA, right? It has A and H for adjacent and hypotenuse. So again, what does a ka in SOHCAHTOA represent? That is saying cosine of theta is equal to A, which is your adjacent, over H, which is your hypotenuse. Fill in everything that you know. Cosine of no longer theta, right? No longer theta, I actually know theta. Cosine of theta is 12. Sorry, cosine of theta is going to be 12 degrees, is equal to my adjacent side, which is 8 over my hypotenuse, which is x. All right, if I can correctly go through and solve for x, then plug it into my calculator, we should be okay. Let's get rid of that fraction. Let's get rid of that fraction by multiplying by that denominator. I multiply both sides by x. On the left, I'm going to have x times cosine of 12 degrees is equal to, my x is canceled out, so it's just equal to 8. I still don't have x all by itself. I need to go through and divide both sides by cosine of 12. Divide both sides by cosine of 12 degrees. Well, cosine of 12 and cosine of 12 cancels out, and I'm left with x is equal to 8 divided by cosine of 12 degrees. If we can correctly plug that into our calculator, it should tell us our hypotenuse, which is our x. So 8 divided by cosine of 12. Clear that. 8 divided by cosine of 12 degrees is equal to 8.178. 8.178. 8.178. And I'm going to go ahead and round that again, 2 spaces after the decimal. So take a look to the hundreds place. There's a 7 to the right of that. There's an 8. We are going to end up rounding this up to 8.18. And again, this is units, right? They don't tell us feet, inches, centimeters. So that is our missing value of x here. That is the distance of the hypotenuse, 8.18 units. All right, let's move on to problem number 3. Okay, problem number 3. For this one, they say Elise is standing on the top of a 50-foot building. So again, here we see the building, right? That measures 50 feet. Okay, and sees her friend. So her friend's down there, Molly. If Molly is 30 feet away from the base, so again, here's the base of the building. She is a distance of 30 feet away. What is the angle of elevation? So again, this time we're trying to find the angle of elevation here. From the base, sorry, what is the angle of elevation to the nearest degree from Molly to Elise? So again, we're trying to find that missing angle. Well, again, we're still going to be using SOHCAHTOA. So let me write that. So we're going to be still using trig here. So let's go through and label though. So where do I put my reference angle, right? This time they don't give me an angle. Well, I'm going to put that reference angle over the angle that we were trying to find, where x is in this case. And let's label directly across. That is your opposite side. So again, this 50-foot building over here, that's considered the opposite. Find that perfect 90-degree corner directly across from that. That is my hypotenuse. And that means that the last one down here, the 30 feet, that is my adjacent. Well, which of these trig functions is going to help us? Which of these 3 trig functions is going to help us? Well, we have the opposite, which is 50 feet. I have adjacent, which is 30. So what uses opposite and adjacent? That is going to be tangent. Remember, the TOA in SOHCAHTOA, that stands for tangent of theta is equal to O, which is your opposite, over A, which is your adjacent. So fill in everything that you know. We're going to go ahead and write tangent of, and normally I would replace theta, but that's what I'm trying to find. I'm trying to find that angle, right? Is it 52 degrees? Is it 45 degrees? What is that angle? So we're going to leave it as theta. It's equal to the opposite side, which we labeled that as 50, over the adjacent side, which is down here, that was 30 feet. Okay, well, how do I get that reference angle all by itself, right? How do I just kick over the tangent to the other side? We have to use the inverse. So we're going to say theta is equal to tangent inverse. That's where it has a little -1 sitting up above of 50 divided by 30. If I can correctly plug this in, it will tell us that missing angle, right? It will go ahead and tell us that missing angle. So let me type that in, tangent inverse of 50 over 30. So clear, how do I get tangent inverse? I hit func for function. Tangent inverse is there. Go back to the main. And then it was 50 divided by 30. Let me just make sure it was 50 divided by 30. I always like to make sure, since we're going back and forth, it is So there we have it, 59.03. So it's going to be round to the nearest degree, 59.03. If I round that to the nearest degree, that is going to be just 59 degrees. So again, our reference angle right there measures 59 degrees. Okay, so that angle right there measures 59 degrees. Okay, problem number 4. Solve for the measure of angle A and the measure of angle B. So again, another problem where we have to find angles. So we actually have to find both of them. So let me go ahead and find the measure of angle A. So let me write SOHCAHTOA before I forget as well. So TOA. Okay, so where do I place myself here? Well, if I'm trying to find A first, right, if we're going after A, let's put ourselves here at A. If that's what I'm trying to find out, let's put our reference angle there at A. Walk directly opposite of that reference angle to the opposite wall. We're going to label that opposite. Here I have my 90 degrees, so let me go across that and label that my hypotenuse. 19 is going to be our hypotenuse, and that means that 5 in this case is going to be adjacent. Well, what do they give us? What are we trying to find? Well, they give us two sides here. They give us the adjacent and the hypotenuse. So which one am I going to use to my advantage? Sine, cosine, or tangent? Not sine, not tangent. We're going to go ahead and use cosine, right? The ka in SOHCAHTOA. So again, what does that represent? That's saying cosine of theta is equal to A over H, adjacent over hypotenuse. Well, fill in everything that you know. Cosine of theta, and again, that's going to stay the same. That's what I'm trying to find, is equal to my adjacent, which was 5, and then hypotenuse, which is over there, which is 19. All right, if I can kick over that cosine by using the inverse, right, we're going to kick it over to the other side. We're going to say theta is equal to cosine inverse of 5 over 19. Let's go ahead and plug that into our calculator. That will tell us the measure of angle A. All right, so theta is equal to, and we'll round this to the nearest whole degree, cosine inverse of 5 over 19. Clear? So function, cosine inverse, and it's 5 divided by 19. We get a total of 74.7 degrees. Let me go back. So there we have it, 74 point, whoops, and I forgot it already. 74.7 degrees, which is going to round to 75 degrees. So the measure of angle A is equal to 75 degrees. Okay, so how can I find the measure of angle B? You could go through that same problem and use sine, cosine, or tangent to help you, right? You can use your trig, or you can remember that whenever you have a triangle, triangle sum theorem says that whenever you have a triangle, how many degrees should be inside that triangle? A total of 180 degrees. Well, we had angle A up here, and we figured out that was 75 degrees. Okay, I also have this perfect corner right here, right? That perfect corner, which is going to be a total of 90. So I'll label it 90. Well, how much more should angle B be over here? Well, again, if you add all three of them together, if you go through and add all three of them together, 75 plus 90 degrees plus that missing angle, that question mark there, I should get a total of 180 degrees. There's a total of 180 degrees when you add all three angles in a triangle. Well, what is 75? Let me change colors here. 75 plus 90, that is 165. Plus my question mark here is equal to 180. If we go ahead and we subtract 165 from both sides, we'll end up with that missing angle. That question mark is equal to what's 180 minus 165. That is going to give us, what is that, 15? 180, let me just double check. minus 165, that gives us 15. It's going to go ahead and give us 15. And again, it's 15 degrees. And that question mark was actually angle B. So we can go back and change that. That's the measure of angle B. Angle B here would measure 15 degrees. All right, measure of angle B would be 15 degrees. Okay, problem number 5. It's saying, what is the scale factor of the dilation? Well, this is getting to the more recent stuff. Remember, scale factor. I'll use SF for short. That is the new over the old. It was just a comparison. It was a ratio. So first of all, which one's the new one? Which one is the old one? So I see here that I have V prime, U prime, T prime, S prime. So again, those primes are telling me that, hey, this one is going to be the new one. The bigger one out here was the older one. All right, so if taking a look at it, going from the older one to the newer one, it was a reduction. It got much smaller. My scale factor should be something between 0 and 1. I'm going to go ahead and use the sides, the top side of both of these. So for the new one, from V prime to U prime, that measured 1, 2, 3, 4 units. So the new one here, my scale factor should say 4 over, let me compare it to the same side on the old one from V to U. This was 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's a distance of 20. So when you put that together, that's your scale factor, 4 over 20. But of course, we do want to do better and simplify. We can divide 4 and 20 by 4. And we're going to get that our scale factor here is equal to, what's 4 divided by 4? That's 1. 20 divided by 4 is 5. So there is our scale factor. Our scale factor is 1/5, right? And we can see going from the old one to the new one, it's 1/5 of its size. It got shrunken down to 1/5 of its size. All right, problem number 6, it says, what is the new length from A prime to B prime after a dilation centered at point A with a scale factor of 1/3? So there's a lot going on here. So centered at point A. So this isn't from the origin. So we're going to be centered at A. So A, imagine you put a thumbtack on there. It's not moving, right? You glued that one down. It's going to be A, but it's also going to be A prime. That one is not moving. It's not moving at all. It's asking, what is the new distance from A prime to B prime? So take a look at the original distance from A to B. From A to B used to be 1, 2, 3, 4, 5, 6. 6 units. Well, whoops. Well, now we're applying a scale factor of 1/3. Well, when you apply a scale factor of 1/3, right, you're just really multiplying by 1/3. Let me show my work here. So that distance that used to be 6, it's now going to be what? Well, it's 6 over 1. Multiply across the top. 6 times 1 is 6. 1 times 3 is 3. 6 divided by 3 is 2. That is going to be your new length. The length from A prime to B prime, that is going to be a length of 2 units. Okay, so that distance got shrunken down and it's only going to go over 2 spaces. This is where your new B prime should be, right? That is the new B prime side there. And again, it's just a distance of 2. You could go through and dilate the rest of the triangle, but it was just asking from A prime to B prime. Okay, problem number 7 here. It says a triangle has vertices 0, 2. So I'll write it out, 0, 2, 2, -1, and -2, -2. It is a dilation with the center of the dilation at the origin. So again, when we're dilating from the origin is the center, 0, 0. Use the coordinates. We're going to go ahead and use those coordinates. All right, so when I dilate from the origin, I can use the coordinates. And we're going to apply a scale factor of 2. Scale factor of 2. And it's asking what are the vertices after that dilation. So when we apply our scale factor, we're just going through and multiplying every x and y value by that scale factor of 2. So what are going to be the new coordinates? Just go through and multiply. So for this first one, 0 times 2 is 0, 2 times 2 is 4. For the next one, 2 times 2 is 4, 2 times -1 is -2. And then for the last one, 2 times -2 is -4, and the same thing again, -4. These are your new coordinates for your new vertices.